Hello everyone, welcome back to this series on simple AC circuits. In this video, I'll be teaching on the types of AC circuits. So the first type of AC circuit we are going to be discussing is an AC circuit that contains a resistor. So we'll call it resistor in an AC circuit. So this circuit is an AC circuit that contains a resistor. So what is a resistor? A resistor is any material that opposes the flow of current through it. So let's look at the diagram for this circuit. This circuit contains a resistor. And remember, in this circuit, an alternating current is flowing. So this is a diagram of an AC circuit containing a resistor. That's the resistor, and this symbol indicates an alternating current is flowing through this circuit. In this circuit, there are two things that are very important. The first is the resistance. And the resistance in this circuit can be gotten from our Ohm's law. Remember that Ohm's law, the mathematical formula for Ohm's law is that V is equal to IR. So from our Ohm's law, we can calculate or we can derive a formula for the resistance. So making our R the solid formula, we now have that the resistance R is equal to V over I. So this is the first thing we need to take note on this type of AC circuit. The second thing we need to take note is that in this circuit that contains a resistor, the current and the voltage are said to be in the same phase. The current, let's represent the current with IR. The current and the voltage, let's represent the voltage with VR. The current flowing in this circuit and the voltage in this circuit are in the same phase. So we're saying that the current and the voltage are in the same phase. And what it means is that the current and the voltage attain their maximum value, minimum value, or zero value at the same time. So in this circuit, we say that the resistance is equal to V over I. And the second thing is that the current and the voltage are in the same phase. The second type of AC circuit we're going to be discussing is a circuit that contains a capacitor. So we'll call it a capacitor in an AC circuit. A capacitor is a device that is used for storing electric charge. And we represent a capacitor with a symbol. So the two lines must be equal. So that symbol represents a capacitor, and a capacitor measures the capacitance, and the unit is in farad. So the unit of our capacitance is farad. So let's see the diagram for this circuit. So this circuit contains a capacitor, and there is an alternating current flowing in this circuit. So this is a diagram representing this second type of circuit, capacitor in an AC circuit. So in this diagram, we can see our capacitor, and this capacitor is in a circuit in which alternating current flows. There are two things that are important in this circuit. The first is that the current flowing through this circuit, let's represent it with IC because we are talking about capacitor. So the current flowing in this circuit and the voltage are out of phase. So we're saying that the current and the voltage are not in the same phase. So what it means is that the current leads the voltage by a value of what? 90 degrees, or 1/4 cycle. So in this circuit, the current is leading the voltage. So the current attains its maximum value before the voltage. So that is what it means, that the current leads the voltage. So if the current is leading the voltage, then it means that the voltage is lagging behind the current. So another way of putting it is that the voltage lags behind the current by the same value, by a value of what? 90 degrees, or 1/4 cycle. So the second thing that is important in this circuit is the opposition offered by this capacitor. The capacitor also offers opposition to the flow of current, and the opposition to the flow of current offered by a capacitor is called the capacitive reactance. We said that the resistor in the previous circuit, that the resistor offers opposition to the flow of current, and that opposition is called resistance. But in this circuit that contains a capacitor, the opposition offered by this capacitor to the flow of current is called the capacitive reactance, and it is represented with the symbol XC, and it's also measured in ohms. So the unit of capacitive reactance is ohms, which implies that it is a resistance. So mathematically, the capacitive reactance XC is equal to 1/2 pi FC. So if we are to calculate the capacitive reactance, then we're going to use the formula that capacitive reactance is equal to 1/2 pi FC, where our F is the frequency and our C is the capacitance. So this is our formula for finding the capacitive reactance. Also, we need to take note that the Ohm's law for this circuit will now be that V is equal to IXC. So this becomes our Ohm's law for this circuit, that the voltage is equal to the current times the capacitive reactance. So this is what you need to know about this second circuit called capacitor in an AC circuit. Let's quickly look at the third type of circuit, in which we have the inductor in an AC circuit. The third type of circuit that we're going to be discussing is the inductor in an AC circuit, a circuit that contains an inductor. An inductor is represented with a symbol that looks like this, and an inductor measures inductance, and the unit of inductance is Henry. So the unit of inductance is Henry, H. So let's see the diagram for this circuit. So for this circuit that contains an inductor, the diagram looks like this. So this is a diagram of an inductor in an AC circuit. So this is the inductor in the circuit, and this symbol represents alternating current, which is flowing through the circuit. The two things that are important in this circuit is that in this circuit, the current and the voltage are out of phase. So in this circuit, the current and voltage are not in the same phase. They do not attain their maximum value at the same time. So if they are not in the same phase, then which one is leading and which one is lagging? So in this circuit, the the voltage leads the current by a value of 90 degrees or 1/4 cycle. So in this circuit, the voltage is leading, meaning that the voltage attains its maximum value before the current. And in the same way, voltage attains its minimum value before the current. So if the voltage is leading the current, it means that the current lags behind the voltage by the same value of 90 degrees or 1/4 cycle. So this is the first thing that we need to take note regarding this circuit. Then the second thing we need to take note is that in this circuit, the inductor opposes the flow of current through this circuit. And the opposition to the flow of current offered by this inductor is called the inductive reactance. So the opposition offered by an inductor in an AC circuit is called the inductive reactance, which is represented with the symbol XL and is also measured in ohms. So the unit of inductive reactance is ohms. So to calculate for the inductive reactance XL is equal to 2 pi FL. So this is the mathematical formula for finding our inductive reactance, where F is our frequency, which is measured in Hertz, and our L is our inductance, which is measured in Henry. And the Ohm's law for this circuit is going to be that the V is equal to IXL. So this becomes the Ohm's law for this circuit. Our R is replaced by XL because the opposition in this circuit is called the inductive reactance. So this is the second thing we need to take note regarding this circuit. Having looked at the first three types of AC circuits, let's see some questions on how to solve these three types of circuits. So let's see question number 1. The question says, a 2 Henry inductor has negligible resistance and is connected to a 50/pi AC supply. The reactance of the inductor is dash. So the question is asking us to find the reactance of the inductor. And if you remember, the reactance of the inductor is called the inductive reactance. So this question is asking us to find the inductive reactance. And we know that the inductive reactance XL is equal to 2 pi FL. So this is the mathematical formula for finding the inductive reactance. So let's see our parameters from the question. The question says a 2 Henry inductor. So that our inductance, the inductance of the inductor is 2 Henry, has negligible resistance, and is connected to a 50/pi AC supply. So this 50/pi is the frequency. This is supposed to be Hertz. So a 50/pi Hertz AC supply. So we now have that our frequency is equal to 50/pi Hertz. So we're asked to find the reactance. Having written out our parameter, then we need to substitute our value into this formula. So we now have that our inductive reactance is equal to 2 times pi times our frequency is 50/pi times our inductance is equal to 2 Henry. So times 2. Our pi will cancel our pi. So we now have that our inductive reactance will now give us 2 times 50 times 2, which will give us 200. And remember that inductive reactance is a resistance, so which means that the unit is going to be ohms. So the inductive reactance of the inductor is 200 ohms. Let's attempt another question. So let's look at the second example. So the question says, determine the capacitive reactance when a 10 farad capacitor with a negligible resistance is connected to a 50/pi-Hz oscillator. So the question is asking us to find the capacitive reactance. So to solve this question, we'll start out by writing out the formula for capacitive reactance. We know that our capacitive reactance XC is equal to 1/2 pi Fc. Now we'll write out the parameters that are given to us in the question. The question says determine the capacitive reactance when a 10 farad capacitor. So the first thing we are seeing is our capacitance. The capacitance of the capacitor is 10 farad. With a negligible resistance is connected to a 50/pi-Hz oscillator. So the second parameter we are seeing is our frequency, which is equal to 50/pi-Hz. Now, I've written out the parameters given to us in the question. The next thing is to put our values into our formula. So substituting this value into the formula, we now have that our capacitive reactance is equal to 1/2 times our pi times the frequency is 50 divided by pi. So we now have 50 divided by pi times our capacitance is 10 times 10. So our pi can divide our pi, so the pi will cancel out. We are left with that capacitive reactance is equal to 1/2 times 50 times 10. That will give us that our capacitive reactance is equal to 1/2 times 50 is 100, and 100 times 10 is 1000. So we now have that our capacitive reactance XC is now equal to 1 times 10 raised to the power minus 3. That's 1 divided by 1000 will give us 10 raised to the power minus 3. And remember that our capacitive reactance is a resistance, and therefore the unit is going to be ohms. So the capacitive reactance of the capacitor is 1 times 10 raised to the power minus 3 ohms. So we have been able to see some questions on the first 3 AC circuits we discussed: the resistor in an AC circuit, the capacitor in an AC circuit, and the inductor in an AC circuit. In our next video, we'll be talking about another type of circuit in which this capacitor, inductor, and resistor are combined together. So that type of circuit are called the combined circuit. So in our next video, we'll look at the combined circuit. So I want you to keep watching as I take you along this series on simple AC circuits. If you have enjoyed this video, please click on the like button and don't forget to subscribe to our YouTube channel to get notification on our new videos. See you in our next class.